Welcome to EPG Pathshala lecture series in computer science. This course is on operating systems. In this module, we will learn different file allocation methods and different methods for managing free space in disks. The learning objectives for this module are different file allocation methods and different methods by which free space is managed in disks. So, we all know that file system is the most visible part of the operating system and all files are stored in disks, and it is necessary to allocate space for file in disk. Whenever a file is created, the space for the file has to be allocated in the disk, and there will be the space that is free, and those disk blocks have to be kept track of. So, the operating system should have control over the free disk blocks in the disk, and it also should know which disk blocks are being allocated and for which file the disk blocks are being allocated. So, first we learn different file allocation methods, that is, we learn how disk blocks are allocated for a file in the disk. So, we all know that disk is logically divided into a number of disk blocks. The size of all disk blocks are generally fixed, and it can be say 5 bytes or 1 KB or 2 KB or 4 KB, etc., and so on. So, but the disk block size is fixed. So, the disk being comprised of a number of disk blocks, whenever a file is being created or whenever you write to a file or whenever the size of the file exceeds the current size, then we need to allocate disk blocks for the file. So, the allocation of disk blocks have to be done in such a way that the disk space is utilized effectively and the files can be accessed very quickly. So, here we will learn 3 different types of file allocation methods. One is this contiguous allocation, the other is linked allocation, and the next is indexed allocation. First, we will see this contiguous allocation methods. In this contiguous allocation method, each file will occupy a set of contiguous blocks on the disk, and if only one job is accessing the disk, then accessing say B plus first block after accessing B block will not require any head movement. Only the proper disk proper sector has to be moved under the current head. So, because of this, the disk seeks will be minimal, and this you can see that it is a very simple method. Okay. So, what you need to remember is only the starting disk block number or the starting location, the first disk block number alone need to be remembered, and it also you can also remember the length of the file, which is in terms of the number of disk blocks. So, you need to know which is the starting disk block, and you also need to know the number of disk blocks that are currently allocated to the file. And in this kind of contiguous allocation, it is possible to access a file sequentially as well as in direct mode. So, now look at this figure. Here this is an example of how file is allocated contiguously. There is a file called count which starts from disk block number 0, and the length of the file is 2, that is spans over through 2 disk blocks. So, here you can see that disk block number 0 and disk block number 1 are allocated for this file, and the next file say TR, it starts from disk block number 4 and it spans over 3 disk blocks. So, it starts from 14, 15 and 16 are allocated to this file called TR. So, to know where the file is currently being kept or to know which disk blocks have the contents of the file, you can look into this directories entry. So, the directories entry will have the name of the file, and along with that it will have the starting disk block address, and then you also have the number of disk blocks the file is spanning over. And this is very simple in terms of access, because say if you are looking at sequential access, say if you want to access the first file, you know the starting disk block. So, you can access the first disk block, because it is sequential disk block, you need to access the next disk block immediately. So, you will access disk block number 1 immediately. So, it is easier. Suppose if you want to do a direct access, say consider this file called mail, which starts from disk block number 19 and goes till disk block number 24. Suppose we want to access the third disk block in this file, because you know the starting disk block is 19 from the directory entry, you can calculate that the third disk block is at 21 and you can access disk block number 21 directly. So, it is possible to access the file in a sequential manner, that is starting from the first disk block and going on to the next and to the next and so on, or it is also possible to have a direct access where you can access any nth disk block of that file, say the third disk block of the file or fourth disk block of the file directly without even starting from the first disk block. So, both sequential and direct access are possible with this contiguous allocation of disk space. But the problem here with this contiguous allocation is that the dynamic storage allocation problem comes into picture. That is, suppose if you have a list of free holes and you need to allocate say 5 disk blocks for a file, and you have a number of holes which can accommodate these 5 disk blocks, then where do you allocate space for that file? You can go for one of these two strategies. You can go for the first fit, where you can look at the first contiguous 5 disk block 5 spaces that is free and you can allocate, or you can go for a best fit strategy. Best fit strategy looks for the smallest hole that is large enough to accommodate this. So, you need to look for the smallest space that is large enough to accommodate say 5 disk blocks in the example that I have cited, and you can use either of these two strategies for allocating space. And the next problem with this contiguous allocation is that it is possible to have external fragmentation. That is, once you start allocating and deallocating files and so on, so in due course of time you will have free disk blocks here and there in the disk. You may not have contiguous say 10 free disk blocks, but you may have say 2 disk blocks which are free in one place, 1 in another place, say 2 more in another place and say 5 more in another place, etc. and so on. Suppose if you want to allocate space for a file which needs 10 contiguous disk blocks, you may not be able to allocate because the disk blocks, free disk blocks are here and there, they are not contiguous in one place. So, what we need to do is that you can solve this using compaction. And the next problem is that how you determine how much space is needed for a file. We need to allocate contiguous disk blocks for a file. So, when the file is initially created, it may occupy only one disk block, but the file may grow over time and may need say 10 disk blocks. But how do you know how that the file will need 10 disk blocks even when the file is created? So, only if you know that the file will need 10 disk blocks, you can allocate space for the file at the beginning. So, if you allocate less amount of space for a file which will grow later, it becomes difficult for the file to grow. And suppose if you allocate say more amount of space, say you do not really know how much space a file will occupy. So, what you do, you try to allocate say some 10 or 15 disk blocks, but if the file is occupying only say 2 disk blocks or 3 disk blocks, the remaining disk blocks that have been allocated for this file will go waste. So, it will result in wastage of space. So, what can be done is that you can do a compaction where you find a larger hole and copy the contents to the new space and free the old space. So, when the file grows, if you are not able to accommodate the file within the contiguous disk blocks that are currently allocated to the file, then you need to find a bigger space and copy these file contents to that space and free the old space that are occupied by the file. And another thing is that even if a file size is known in advance, but if the file is going to grow over a long period of time, say initially the file needs only 2 disk blocks, but after some amount of time it will grow to say 3, 4, 5, 6 and 7. Say if it needs say 10 disk blocks, but if it is growing over months or years, then in that case during all this time the disk blocks that are currently allocated to the file will not be used at all. So, this results in internal fragmentation, that is internal to the space that is allocated for the file, some disk blocks are not used at all and that result in wastage of space. So, they try to do a modification to this contiguous allocation, where initially one contiguous chunk of space will be allocated, few disk blocks will be allocated for the file, but when the file grows, if the space is not large enough to accommodate, then what is done? Another chunk of space is allocated, say another few disk blocks will be allocated to this file. This new chunk is called an extent of this file, and this kind of contiguous file allocation has been done in Veritas file system. Now, we move on to another type of disk allocation, that is linked allocation. So, this linked allocation tries to solve the problems of contiguous allocation. Here what is done is that any disk block in the disk can be allocated for the file, and there will be a link that is being maintained between all the disk blocks that are allocated to this file. So, the file is a linked list of disk blocks. The blocks can be scattered anywhere on the disk, and in the directory you will have a pointer to the first disk block of the file and to the last disk block of the file. So, look at this diagram. This shows how linked allocation is being done. You have a directory entry. The directory entry has the name of the file, the address of the starting disk block, that is 9, and then in disk block number 9, along with the contents of the file, you also have this pointer that is being stored, that is the pointer that points to the next disk block which contains the contents of the file. So, the pointer says that it is disk block number 16, and disk block number 16 has the pointer or the address of the next disk block, which says that 1 is the next disk block, and then from there you have a pointer to disk block number 10, and 10 has a pointer to disk block number 25. Disk block number 25 has a pointer which says -1, which means that that is the last disk block that is allocated to this file. And this directory entry also has information about the address of the last disk block where the file's contents are stored. So, here you can see that the disk blocks are not contiguous, they can occupy any place in the disk. Only thing is you have a pointer from one disk block to the other to find out where the next disk block is. The problem here is that, like, you do not have external fragmentation as in contiguous allocation, because in contiguous allocation, like you will have spaces here and there which are currently free, but you may not have it contiguous. But here in linked allocation you do not really need that. You can use any disk block, even if it is one disk block that is free at any other place, you can link it and use it for the file. So, that is an advantage. The second advantage is that the size of the file need not be declared when the file is created, but you need to know that in the case of contiguous allocation. And the next is the file can continue to grow as long as free blocks are available, and compaction is not needed because you do not have fragmentation. The disadvantages here is that the first one is that there is no random access. You can only do a sequential access in this case, that is from the directory entry you have a pointer to the first disk block, and only after moving to the first disk block you can move to the second disk block, etc., and so on. So, only the sequential access is possible. You can access the disk blocks only one after the other, but there is no random access. If you want to access a disk block directly, so if you want to access the fifth disk block directly, it is not possible. You would only have to start from the first disk block, move to the second, then from to the third, and then to the fourth, and only then you can reach the fifth disk block. So, random access is not allowed, is not possible in linked allocation. And the second disadvantage is that the space that is required for the pointers. Each and every disk block has a pointer to the next disk block. So, in each and every disk block you need to store the address of the next disk block. So, if you have 10 disk block for a file, then you will have the addresses of 10 addresses being stored in different disk blocks. So, this occupies space. So, what can be done is that you can collect these blocks into multiples called clusters. So, rather than having one disk block and then having a pointer from there to the next disk block and so on, you can have groups of say 4 blocks. So, from the initial directory entry, it will point to the first disk block, then the first 4 disk block in this cluster can be used, and then from this cluster you will have a pointer to the next cluster, which again will be 4 disk blocks and so on. So, because of this you can reduce this number of pointers, you will have less number of pointers, and because of that you will have few disk head seeks, because you have contiguous 4 blocks. So, it is not needed for the head to move from one cylinder to another cylinder and so on, it is not necessary. And the only disadvantage here is that you have increased in internal fragmentation, because you have 4 disk blocks that have been allocated in a cluster. Say if in the last 4 disk blocks, in the last cluster that has been allocated to the file, say if only 1 disk block is being used and the remaining 3 are not being used, and these 3 disk blocks go waste. So, there is internal fragmentation within the cluster. So, that is a disadvantage when you are using clusters. Then the next problem is reliability. Say what will happen if the pointers are lost? In each disk block you will have a pointer which has been maintained, which points to the next disk block. Now, if this pointer gets lost or if it gets damaged, if it gets damaged, say instead of pointing to disk block number 25, say if it is now currently pointing to disk block number 26, then it is wrongly pointing to the contents of another file or to a free disk block. So, that has to be taken care of. So, to improve the reliability, one thing you can have is that you can have a doubly linked list rather than having a singly linked list, doubly linked list. But if having a doubly linked list, again this use of pointers becomes more, and hence again the problems may get increased as well. And the next solution is to store the name of the file and the relative block number in each block. So, you have a pointer from one block to the other, but when you move to that block you will have the name of the file and say that this is a third block of that particular file, that is also stored in that block. So, that will give a confirmation that this block really contains the contents of that file only. And so, we have a variation of this linked allocation which is being used in the MS-DOS systems in the file allocation table. So, the disk space allocation for files in MS-DOS is done very similar to this. And what is done is that in each volume, at the beginning of each volume, there is a portion of the disk which will contain this FAT or the file allocation table. You can see this diagram of this file allocation table. See here you can see that there is a directory entry which has got the name of the directory, and it also has the address of the starting disk block. So, this file, the first disk block for this file is 217. So, you can understand that is disk block number 217. So, to get the next disk block you have to look into this FAT. So, you have to look into the 217th entry and see that the next disk block is in 618, and so you understand that the next disk block number is 618 for that particular file. Now, to look at the third disk block of that file, look into the 618th entry here in this FAT, you find that it is 339 and the next disk block is in 339. So, and hence you can use 339 disk block. To look the next disk block, look at this 339th entry, 339th entry. So, you see end of file here, which means that that is all is the contents of that particular file. So, here you find that this file is being allocated. So, disk block numbers 217, 618 and 339. So, this is the way in which file allocation table or file space is being allocated for files in the case of DOS. And now we move on to the next type of allocation called the indexed allocation. This indexed allocation, it solves the external fragmentation and size declaration problem of contiguous allocation. It also solves this direct access problem in the linked allocation. So, here what is done is that all pointers are put into one single block which is called the index block. So, rather than having a pointer in each and every disk block as in the case of the previous linked allocation, here we have all the pointers being put into a single disk block, and that is called an index block. And each file will have its own index block, which will have an array of disk block addresses. All the disk block addresses are stored in the index block. So, look at this diagram. Here you find that you have a directory entry, the name of the file is given, and you also have the address of the index block that is kept in the directory entry. So, from here you find that the index block is 19 and the index block will look something like this. It will have a list of disk block addresses which contains the contents of the file. So, it says that disk block number 9 is the first block, disk block number 16 is the second, 1 is the third, 10 is the fourth and 25th is the fifth. So, all these 5 disk blocks contain the contents of this file. So, the ith entry in the index block will point to the ith block of the file. So, here it is possible to have sequential as well as direct access because you can access the ith block by looking into the ith entry in the index block. And there is no external fragmentation because you do not allocate contiguous space. You can use any disk block that is free can be used and hence there is no external fragmentation. But the problem is you have more pointer overhead when there is a file which is occupying only 2 blocks. In the case of linked allocation, you need to allocate space only for 2 pointers, but here you need to allocate one single index block, one full block which will have only 2 entries. So, there is wastage of space. And another thing what you need to look at is that how large the index block should be. So, because you have only 2 entries, the whole index block is being used. So, maybe we may think that we need to use a smaller index block because lot of space is getting wasted. But if the index block becomes too small, it may not be large enough to hold all pointers if it is a larger file. So, that is again a problem. Suppose say you have a file, the size of the file is say 256K, 256K is 2 power 18 and you need to accommodate this file in the disk and each block in the disk is 2 power 9. So, the file will occupy 2 power 18 divided by 2 power 9, it will occupy 2 power 9 disk blocks. Now, for an index block suppose you are allocating one block for index block and the index block will have 2 power 9 entries. So, we need only one block for the index table. So, what is being done here is that you can have different variants of this index block. So, one way is to have a linked scheme that is linked together all the index blocks. So, if you have more than one index block, then from one index block you can have a pointer to the next index block, or the first index block will have the address of the next disk block which is the next index block, and from there you can have the address of the next disk block and so on. So, this is called a linked scheme. The next variant of having multiple index blocks is that to go for a 2 level index. You will have a first level index block and each entry of this first level index block will point to another index block. So, each entry will be an index block, will point to the second level index block, and the second level index block you will have addresses of disk blocks and those will point to the disk blocks which will have the contents of the file. So, you can see, look at this example where a directory entry is pointing to an outer index block. The outer index block in turn, each entry is pointed to another index block and each of these index blocks will point to files. So, because of this you can have a larger file size. Suppose if this index block has got 512 entries and this entry will point to another 512 entries and each of these entries will be this will point to 512 disk blocks. So, you will have 512 into 512 into 512, 512 cube size, 512 cube can be the size of the file that is being referred to by this index kind of indexed allocation. And you can also have a combined scheme where you can have direct blocks as well as indirect blocks, which is being used in UNIX. So, this is the inode of the UNIX. Metadata of file for UNIX is kept in an inode. So, here you have the mode owner, timestamps, all these are kept in inode. In addition to that, you also have the addresses of disk blocks that are kept in the inode. So, you have direct blocks which have the addresses of direct disk blocks. This will have addresses of disk blocks which can contain the contents of the file, and this will be 12 in number. And if the size of the file goes beyond this, this will have the single indirect will have a pointer to one disk block, which will in turn have the addresses of disk blocks containing the contents of the file. So, you have an address of an index block, the index block in turn having the addresses of disk blocks. And even if the size goes beyond this, you can use a double indirect where you have a pointer to an index block, the index block in turn pointing to a number of index blocks, that in turn pointing to a number of disk blocks. And you can also have a triple indirect and so on. So, you can have multiple ways in which you can use this indirection. So, if the file size is very small, then it will occupy or use only these direct disk blocks. So, here the size of each disk block is 4K bytes. So, initially you can have 48K that is being addressed by these 12 entries. You have 12 direct disk block addresses here. So, if the file size goes beyond 48K, only then it will use a single indirect or double indirect and so on. Now, we look at this topic, that is free space management. This is nothing but how to keep track of free disk space. You have free disk blocks that are kept in the disk. So, how do we keep track of this? We need to keep, the operating system needs to keep track of that. So, we need to reuse the space that are got from deleted files, and those space will have to be used for new files that are being created. So, there is something called a free space list which will record all the free disk blocks that are kept in the memory. So, whenever you create a new file, you look into this free space list to find out disk blocks that are free and allocate for the file that is being created, and remove that space from the free space list after being allocating to the file. So, if a file is deleted, you can add the space to the free space list. So, there are different ways in which this free space list can be maintained. One is this bit vector, that is, you have a bit that is being assigned for each and every disk block, and if a disk block is free, then the bit is corresponding bit is 0. If the disk block is occupied, then the corresponding bit is 1. Suppose if disk blocks say 2, 5, 8, 22 are free, then the corresponding bit vector will look something like this. You will have disk block number 0 which is currently occupied, disk block number 1 which is occupied, and hence the bits are 1, and disk block number 2 is free and hence the bit is 0, etc. and so on. So, likewise you get a bit vector which shows which disk blocks are free and which are currently occupied. And this mechanism is simple, and it is easy in finding the first free block. It is easy to find out, say, m number of consecutive free blocks and so on. So, what you can do is you can sequentially check each word in the bitmap to see whether the value is 0 or not, to find a particular free disk block. And it is also possible to calculate a particular block which is free by calculating likewise, that is you can have the number of bits per word into the number of 0 value words plus offset of first bit. That is, if you have say 8 bits per word and you need to find out the number of 0 value words, if the bits are 0, then it means that it is been occupied, and hence you find out, you move across all those 0 and try to find out the first 1 bit. But the problem here is that the bitmap will be kept in the main memory and it will occupy extra space in the main memory. Say for example, say you have the size of a block is 2 power 12 bytes, and says the size of the disk is 2 power 30 bytes, and hence the number of blocks that are kept in the disk is equal to 2 power 30 divided by 2 power 12, it is 2 power 18. So, you have 2 power 18 disk blocks, which means that you need 2 power 18 bits which is needed to represent each of these disk blocks. So, the number of bits is 2 power 18, or you will have 32K bytes. So, if you want to keep 32K bytes in the main memory, then that is an overhead. And if the size of the disk becomes much larger, say if it is a 1 TB disk, and if you have 4 KB block size, then it will need say 256 MB to store the bitmap. So, they try to use a variant of this bitmap, that is they have something called a linked list, that is all the free blocks are linked together using a linked list. So, you first maintain a pointer to the first free disk block, and from there you will have a pointer to the next free disk block and so on. you just remember the first free disk block and cache it in memory. So, because it is necessary, it is needed only, it is enough only to have the first disk block, the address of the first disk block, and once you access the first disk block, you will have a pointer to the next free disk block and so on. So, this shows how free space is maintained on disk. The free space head will point to disk block number 2, which is free. From 2 you will have a pointer to 3, which is free, etc. and so on. So, with this it is very difficult to get contiguous space, because you will have free disk blocks here and there. Getting contiguous space is difficult. If you have contiguous space, then you will need only less number of seeks of the head, but there is no wastage of space because you can use any disk block that is kept in the disk. So, traversing the list here will take some amount of time, but rather than doing that, what can be done is that you can usually allocate the first disk block which is free and then move the head to the next free disk block, so that it will take less amount of time to find a particular free disk block. So, the FAT actually, what we had seen just before, it incorporates this free block accounting along with the allocation, file allocation data structure. The next method is to group disk blocks. So, rather than having a link from one disk block to another disk block, another free disk block, here we have the addresses of n free blocks that are kept in the first free block. So, you will have one free block which will store all the addresses of all the free disk blocks in it, and if this block becomes full, then this will point to another free block, which in turn will have the addresses of another set of free disk blocks. And because of this, the advantage is that a large number of free blocks can be easily found, quickly found by looking into one disk block. And the next method is that, say if you have say 5 free contiguous disk block, in the previous method you will put down all the free disk block numbers one after the other in this free disk block, in that index block kind of thing. Rather than putting contiguous 5 disk block numbers into the free disk block, what you can do is that you can maintain the address of the first disk block or keep the address of the first disk block and say how many disk blocks are free after this first disk block. So, the first free block and the number of free blocks, contiguous free blocks after this first block is maintained. Say if you have disk block number 5 free and till 10 if it is free, you can say that from 5, 6 blocks are free. So, 5, 6 need to be maintained. So, because of this, the advantage is that you will have less number of entries. So, each entry will be a disk address and a count, and the overall list will be shorter. So, summary. So, we learned different file allocation methods like contiguous allocation, linked allocation and indexed allocation, and we learned different methods with which free space in the disk is managed, like bit vector, linked list, grouping and counting. References. Thank you.